and 8th graders. We're here with lesson 6-4 on solving equations with variables on both sides. To solve, you have to bring all the variable terms to one side first. So here we go. We have example A. So here I have a 3h and here I have a 5h. You could either bring the 3h over here or you could bring the 5h over there. The only thing, it doesn't really matter which way you do it, the only advice I will give you is if you have one that's negative, it's usually easier to move that one so I can be dealing in the positives by adding. So I'm going to do that. So I have negative 5h, I'm going to add a 5h. I'm taking the whole thing, the 5h is joined together, and that crosses off. And whatever I did over there, I need to do over here. So I'm adding a 5h. So now I have 7. 3 plus 5 is plus 8h equals negative 1. I always move my variable before I simplify anything else. All right, and from here we know what to do. All right, I just walked you through that whole thing, but apparently it was off the screen. So just to give you a recap of what happened here, we subtracted 7 from both sides. We got 8h equals negative 8. I divided by 8. I got h equals negative 1. And then I went back and I checked my work by plugging negative 1 into this h and into this h and seeing if this side equaled this side, which it did. So this works. Okay, example B. I would like you to try example B. So move your variable. Neither of them are negative, so I would move the smaller one so that way you don't end up with a negative 1. You're going to move this B first and then solve. Example C. We've got some good old-fashioned distributive going on here. So first I need to do that. I've got negative x equals 9x minus 9 times 10, which is 90. Now I need to combine my variables. If I move my x over here to prevent it from being negative, I'll have to then move the 90 over here. Ooh, let's do it both ways. I'm going to rewrite this problem over here. So on this side, I'm going to move my x plus x plus x. And if I got rid of both of those things, then I have 0. So 0 equals 10x minus 90. Now I'm going to add 90 and add 90. And I'll get 90 equals 10x. Divide by 10. Divide by 10. And I get x equals 9. All right, let's try it this way. So on this side, I'm going to move here. I'm going to subtract 9x, subtract 9x. Negative x minus 9x is going to give us negative 10x equals negative 90. Divide by negative 10, divide by negative 10, and I get x equals 9. See, either way that you do it, you'll get the same answer. So in this case, which one was easier? Probably this one. There was less steps, but it did involve me knowing that negative 1 plus negative 9 is negative 10. So you can make your decision which one you want to do. Let's go to page 2. We have a word problem. You may need distributive in order to move the variables, and I just showed you that. And this is example D. You are doing an experiment. You start with 2 plants. Plant A is 5 centimeters tall and plant B is 8 centimeters tall. Plant A grows 2 centimeters per day and plant B grows 1.5 centimeters per day. In how many days will they be the same height? So I'm going to use an equation because I have 2 things that I want to equal each other. On this side, I've got plant A. So right now it's 5 centimeters. And it's growing 2 centimeters per day. So I'm going to add that to 2 centimeters per day. We don't know how many days there are, so we're just going to do 2D. And then on this side, we've got an 8 centimeter plant, and we're going to add that to the fact that it's growing 1.5 centimeters per day. So we're going to subtract 1.5 days and subtract 1.5 days, and I will get 5 plus 0.5 days equals 8. I did it again. I brought it off the screen. So here I subtracted 5, 0.5 days equals 3. I divided by 0.5, divided by 0.5, and I got D equals 6. Remember that dividing by 0.5 is the same thing as multiplying by 2. Dividing by half, same thing as multiplying by 2. So it is going to take 6 days for them to catch up with each other. I have no idea why the book said that this is how you use the distributive property. We didn't use the distributive property here. Oh, funny times. Okay, so anyway, that's how you solve this problem. I look forward to seeing you tomorrow in class. Go ahead and get to work.